Hello, my name is Christian Heinen, and I am a member of SAC Motorsport. I am currently studying mechanical engineering, and I'm transferring to UTSA in the fall. I'm going to talk to you about my role on the SAC Motorsport team. My role was to design and model the new frame that is lighter and stronger. This role helped me understand the design process, but I'll talk more about that later. Odyssey is the name of SAC's third car, a hydrogen fuel cell powered car designed by SAC Motorsport members in 2019 to compete in the Shell Eco Marathon. The Shell Eco Marathon is a showcasing of engineering schools who each design and build the car using a propulsion method like gasoline, lithium-ion batteries, or hydrogen fuel cell, in which the goal is to have the most fuel-efficient vehicle. The current team originally meant to give Odyssey an upgrade, but upon further inspection, due to these three problems, the team decided that redesigning the car would be a better solution to solve all of these problems. One, improper mounting of the shell to the frame. Two, excess material used throughout the frame, adding extra weight that could be removed. And three, a flexing problem due to the inability of the material to support the weight of the driver, all of these affecting fuel efficiency. The shell for Odyssey didn't quite fit exactly right, where one side of the shell hung lower than others, and without proper support for the shell on the frame, the holes didn't line up, which would let air into the cabin, which would slow the car down. Odyssey also used a fiberglass composite floor that ran across this whole span of the bottom of the car, weighing in at about 22 pounds. A lot of material on this floor was not being used to stand on or anything else, which could be classified as excess material that could then be shed in order to save some weight. Rather than reinforcing the old material with aluminum L brackets and adding more materials or weight, the team decided that creating a frame skeleton using all-light super magnesium is the way we wanted to go. My role led me to research super magnesium to make sure that it was suitable for the project that motorsports had. Magnesium is the most common structural material used today, with it being 75% lighter than steel and 33% lighter than aluminum. It makes magnesium a prime candidate. To give you an idea of the density of aluminum versus magnesium, aluminum is 2.7 grams per centimeter cubed, while magnesium is 1.8 grams per centimeter cubed. So a difference of 0.9 grams per centimeter cubed really adds up. I modeled the frame using Autodesk Inventor, a 3D modeling software with a program within Inventor called Frame Generator, which would take the 3D drawing I created using lines and replacing them with a metal tubing profile, where I could mix and match possible sizes for the frame. To maximize rigidity, while also saving as much weight as possible, I ended up using two profiles, one rectangular and one square tubing to use to weld together and create our frame. 2 inch by 1 inch by 1/8 of an inch for the outer shape of the frame, and 1 inch by 1 inch by 1/16 for the supports within the outer shape of the frame. The design process I approached creating the frame taught me a lot of all of what goes into itself. I went through 4 or 5 different models before reaching a final model that still ended up with one final tweak. There was a lot of, here is my design, it would be discussed, I would change it according to the discussion, and come back and repeat that process. This led me to decide to use existing parts to save time. The frame was now designed, but how the back wheel mounted to the frame was still not figured out. I ended up using a swing arm, which is apart from a rear end of a bike where one can change the tire out easily for 2 main reasons. Odyssey had a complicated process to remove the back wheel, so this would be simplifying that process. 2, figuring out how to mount the swing arm to the frame would save time and increase sustainability. One of the goals of Shell Eco Marathon, and a personal goal of mine, is sustainability. Rather than creating more parts from scratch, there is a whole world of parts that can be upcycled and used. Due to the supply issues of magnesium, tubing was very hard to come across. Either the supplier didn't have the right profile sizes, the material was very expensive, or the shipping would take a long time to be received. So the team chose the next best thing, which was aluminum 6063. Moving forward, the team is looking to practice welding on steel to prepare to weld the aluminum frame together. I am looking forward to the process in the fall and all that it has in store. Thank you so much.